LangGraph versus LlamaIndex. Architecting production-ready AI agents. This is a structural guide to deploying orchestration and data layers in the modern AI stack. Here's the misconception. Viewing these frameworks as competitors forces a false choice between reasoning and knowledge. The reality is different. When building enterprise AI systems, the question isn't which tool to use, but which layer of the stack you are currently engineering. Picture the modern AI architecture stack as 3 layers. At the base, foundational large language models provide raw semantic understanding and generation. Above that, LlamaIndex handles knowledge retrieval and retrieval-augmented generation, managing what external truths and domain-specific data the models can access. At the top, LangGraph handles agent orchestration and state, managing how components communicate, make decisions, and persist memory. LlamaIndex operates as the data engine, with a focus on retrieval-augmented generation. It originated as GPT-Index, purpose-built to connect foundational LLMs to private, domain-specific enterprise data. It handles the complete ingestion, indexing, and semantic retrieval pipeline, taking raw documents through chunking and parsing into embeddings, into a vector store, and out through a query engine. It's optimized for sub-second latency and high-volume document extraction. LangGraph operates as the orchestration engine, with a focus on multi-agent coordination and stateful workflows. It evolved from LangChain to handle complex workflows that traditional directed-to-cyclic graphs simply cannot. Agents, tools, and evaluators pass control back and forth in a cyclical loop, with human approval gates along the way. Because it provides durable execution, workflows persist through failures and resume from checkpointed states instead of starting over. Laid side by side, the boundaries become clear. LlamaIndex is built around linear, retrieval-driven workflows for short, query-based tasks, tracking document context and metadata. Its primary use case is enterprise knowledge and semantic search. LangGraph is built around cyclical, stateful graphs for long-running, durable execution, tracking conversational and workflow state. Its primary use case is autonomous multi-agent systems. Think of it as a tale of 2 memory systems. LlamaIndex manages semantic memory, the persistent facts about the world, and enterprise metadata. It tracks what is true. LangGraph manages working and episodic memory, the agent's active workspace, and conversation history across sessions. It tracks what just happened. AI agents fail silently. A hallucinated answer can still return a perfect HTTP 200 in under a second. LlamaIndex logging typically gives you basic query execution and retrieval results. LangGraph tracing goes much further, offering full execution tracing, intermediate state capture, and time travel debugging so you can replay alternative paths and actually find where the silent failure happened. This is why standard pipelines break in production. Traditional retrieval-augmented generation correctly answers complex queries only about 34% of the time. Agentic RAG pushes that to 78%. The gap comes from 3 bottlenecks. Context poisoning, where a single retrieval step isn't enough for multi-hop reasoning. Context distraction, where semantic similarity isn't the same as relevance and the model gets pulled off track by noisy context, and infinite loops, where without stateful orchestration, agents get trapped repeating the same failed path over and over. So when should you optimize for LlamaIndex? 3 catalysts. Semantic search, when query volume is too high to justify per query LLM reasoning loops. Document interaction, when sub-second latency is strictly required for the user experience. And enterprise knowledge, when the system needs to ingest and parse mixed, messy data types like PDFs, APIs, and SQL. And when should you optimize for LangGraph? Also 3 catalysts. Multi-agent workflows, when you're coordinating several specialized AI personas to complete one massive task. Self-correction, when workflows require cyclical reasoning and retry logic to recover from API or logic failures. And human-in-the-loop, when high-risk actions require pausing for human review and approval before execution. The real mastery is synthesis. Combine both tools. Orchestration layered over robust data retrieval. LangGraph orchestrates the workflow, handles conversation state, and routes intent. When facts are needed, it calls into LlamaIndex, which executes high-fidelity ingestion, indexing, retrieval, and ranking, and hands back verified data. The 2 frameworks aren't rivals. They're different layers of the same stack. Here's the architectural decision framework. Start with data. Scale with logic. Ask yourself, do you need complex, multi-turn agent logic and state memory? If yes, reach for LangGraph. If no, do you need to connect foundational LLMs to private enterprise documents? If yes, reach for LlamaIndex. And if you need autonomous agents that reason over private enterprise data, the answer is to integrate both. Start with LlamaIndex to ground your LLM, Then add LangGraph when your pipelines require complex reasoning, looping, or durable state persistence.